Alright, so we're going to talk about significance tests and the four-step process. Again, dealing with our state, plan, do, and conclude. Okay? So, with our 4 steps, let's look at what we need to talk about for each one of these steps. Okay? So we're starting out with state. Again, you write that out when you're working through these problems and list what it wants. So in the state part, you're going to label the parameter that you're talking about for the problem. Then you want to have the statistic that you're going to be talking about in the problem. Your hypotheses to determine whether or not you're going to go with your null or alternative hypotheses, as well as, in this case, when you're dealing with significance tests, you also want to have your significance level. Right, you want to have that so that you know what you're going up against when you're looking for your hypotheses and you're dealing with your p-value. So you need to have all 4 of these labeled in your state part. Alright, so you need to have your parameter, your statistic that you're dealing with for the problem, your hypotheses, and significance level. All of those. Your next set is going to be for your plan. In your plan, you need to name your plan that you're going to use. Okay? So with these, for today, since we're going to be dealing with majority of these, we'll be talking about your proportions. So we're going to talk about a 1 sample z-test for p, and you'll see that in the example we go over. But you'll need to name it, and then for your plan, you need to have all conditions. Conditions met. Now, again, for your conditions, remember those are going to be your random. You're going to have your 10% rule. And then you need to have large counts. Okay? Now, also, too, if you were dealing with means, large counts, or essential limit theorem. For the next part, the do part, it's a pretty simple part, right? Most of you do that no problem. You can all calculate the numbers and get things rolling for that. Again, the best thing is to have the general formula that you're going to be using. Now, that necessarily doesn't have to be written out as far as in the letter format. You can actually just use the numbers. So don't worry about that. As long as you get the formula, the general formula labeled out in some form, the best part is to have a picture of your approximately normal curve and label it with your n and then your mean and standard deviation for the normal curve. Then you actually show the work. You want to show the work, the calculations. Again, with those, you need to have for your work, if you need to find a test statistic, which that's also called a what, guys? That's called a z-score. Okay, and that's going to equal the statistic minus the null or the parameter, right? Actual null value, all that divided by the standard deviation. And that can be labeled as simply saying z, and for the proportions with your p hat, minus p over the standard deviation. And again, the standard deviation formula for that is with your p, the square root of p times 1 minus p, all divided by your sample size. Okay? And then, for the last part, once you have all that work done, you actually want to have just the answer. As far as what your p-value you came up with. According to the z-score, what's your p-value? What's the area under that curve that you were able to calculate depending upon what they're asking for? And then for the last part, you want to deal with your conclusion. Okay? So you conclude. Again, state, plan, do, and conclude. So on conclude, in this case, depending upon your p-value, if it's greater than or less than a significance level, you would say that we do or do not have convincing evidence against the null. Convincing evidence against the null. Okay? And that again is all dependent upon your p-value you get and when you compare it to your significance level, right? So that is going to be your 4 steps. Again, when you're asked to, let's say, does the data provide convincing evidence for proportions, when you're asked to prove significance tests and you're dealing with hypotheses, you have to go through these 4 steps. You cannot just list the do part and the conclude part and it'll be all good. You have to label the state, plan, the do, and conclude. You get full credit for these. Alright, so let's go through an example here real quick and see how this plays out.
Hi, this is Jason Molesky. In this example, we'll take a look at performing a significance test about P. The potato chip producer of section 9.1 has just received a truckload of potatoes from its main supplier. Now recall that if the producer finds convincing evidence that more than 8% of those potatoes have blemishes, the truck is going to be sent away to get another load from the supplier. Suppose a supervisor selects a random sample of 500 potatoes from the truck and an inspection reveals that 47 of those potatoes have blemishes. Let's carry out a significance test at the 5% significance level and then determine what the producer should conclude. To do this, we'll follow our 4-step process, starting by stating the problem. We want to perform a test of the hypotheses, the null hypothesis, p equals 0.08, against the alternative, p is greater than 0.08, where p is the actual proportion of potatoes in the shipment with blemishes. And again, we'll use an alpha equals 0.05 or a 5% significance level. Now, under the plan step, we need to check our conditions. If they're met, we can do a 1-sample z-test for the population proportion p. We took a single sample. We're interested in determining something about the population p, so that 1-sample z-test is appropriate. Well, first of all, we need to check for randomness. Note the supervisor took a random sample of 500 potatoes from the shipment, so that condition is met. Next, for our 10% condition, we can state it seems reasonable to assume that there are at least 5,000 potatoes in the shipment. We'll assume it's a fairly large truck and there's lots of potatoes in there. Finally, we need to check our large counts. Now, assuming that the null hypothesis is true, the expected counts of blemished and unblemished potatoes would be 40 and 460 respectively. We find that by multiplying our sample size times the null p, the 0.08, and then our sample size times 1 minus that value. Now, because both of these values are at least 10, we should be safe doing normal calculations. So it looks like our conditions are met and we're safe doing a 1-sample z-test. Next, we'll finally do the problem. Now note the sample proportion of blemished potatoes is p hat equals 47 out of 500, or about 9.4%, 0.094. Now that's greater than our null hypothesis of 8%, but we have to determine if that's great enough to be considered significant evidence against that null. To do that, we start by calculating a test statistic. We standardize that value to find a z-score of 1.15. Next, we use table A or technology to find the p-value. How likely is it that we'd observe that particular sample or something more extreme, assuming that null hypothesis is true? In this case, either using table A or technology, we see that the p-value is 0.1251, or about 12.5%. Finally, we conclude. Now, because our p-value of 0.1251 is greater than our alpha level, we fail to reject the null hypothesis. In context, that means there's not convincing evidence that the shipment contains more than 8% blemished potatoes. As a result, the producer can use this truckload of potatoes to make potato chips.
Alright, so as you can see in that example you saw, all 4 of these steps, state, plan, do, and conclude, were listed out and explained. to get the answer and get their final conclusion for their p-value based upon the significance level to find out whether or not they had convincing evidence or not. Now the next lesson part we're going to go over here, next little trick to this is, most of these times you've been dealing with your hypotheses for your alternative. So again, your null is going to be p-value equals whatever value they give you. And your alternative, you'll mainly be dealing with greater than or less than. But there's a little trick that if you have a two-sided, a not equals, right? So it's not equals, again, that could be greater than or less than that value. So in which case, you'll see when we're talking about this, let's say you have a normal curve here, right? With your mean and your standard deviation. And let's say you've got your p-value, your z-score, let's say is a negative value right here, so you got a negative z-score. But if it's not equal, not only do you gotta find the area from that z-score less than, but also the positive value of that z-score. So let me put a dash line there. So the positive value of that z-score, and shade this way. So the not equal to two-sided, meaning you're going to need greater than or less than that z-score that you come up with, okay? So to do that, the only thing you have to do is, once you find the value for either the less than, the z-score, or greater than, you're going to take that p-value and you're going to multiply by 2. Pretty easy little fix, right? So multiply by 2. So the p-value, and multiply that by 2. Therefore, you get the true p-value for not equal. In other words, two-sided, because you're getting the lower inside as well as the upper inside for the positive. Okay, so let's go through another example here and let you see how that plays out.
Hi, this is Jason Molesky. In this example, we'll take a look at a two-sided test. According to the Centers for Disease Control and Prevention, the CDC website, 50% of high school students have never smoked a cigarette. Taeyeon wonders whether this national result holds true in his large urban high school. For his AP Stats class project, Taeyeon surveys an SRS of 150 students from his school. He gets responses from all 150 students, and 90 of them say they have never smoked a cigarette. So what should Taeyeon conclude? Make sure to give appropriate evidence to support the answer. Well, let's do the 4-step process for a significance test. We'll start by stating our problem. We want to perform a significance test of the hypotheses null hypothesis p equals 0.50 against the alternative p is not equal to 0.50. Notice this is two-sided because we aren't testing to see if the proportion at Taeyeon's high school is higher or lower than 50%. We just want to see if it's different. And again, p is the proportion of all students in Taeyeon's school who would say they've never smoked cigarettes. Because no significance level was stated, we'll use an alpha of 5%. Well, first we need to check our conditions, and if they're met, we'll do a one-sample z-test for the population proportion p. For the random condition, notice Taeyeon surveyed a simple random sample of 150 students from his school, so that condition is met. For the 10% condition, it does seem reasonable to assume that there are at least 1,500 students in a large high school. This would be 10 times Taeyeon's sample size. Next, for large counts, we have to assume the null hypothesis is true. And if that's true, the expected counts of smokers and non-smokers in the sample would be found by taking our sample size times p sub 0, or 50%. 150 times 50% gives us 75. And again, 150 times 1 minus 50% gives us 75. Both of these values are at least 10, so we should be safe doing normal calculations. Next, we'll actually do the calculations. Well, the sample proportion of non-smokers for Taeyeon is 90 divided by 150, or 60%, 0.60. For the test statistic, z will come out to be 2.45. And for our p-value, using either the table
Or we could use technology. We find that the probability z is greater than or equal to 2.45 is 0.0071. That's the right-tailed area for this particular z value. Now to find the desired p-value, we're doing a two-sided test, so we'll need to double that. So the actual p-value for this two-sided test is 0.0142. Finally, because our p-value 0.0142 is less than alpha equals 0.015, we'll reject the null hypothesis. We have convincing evidence that the proportion of all students at Taeyeon School who would say they have never smoked differs from the national result of 0.50.
Alright guys, so after looking at that for the two-sided example, hopefully it made a little bit more sense and understanding what we're talking about with taking the p-value, multiplying by 2 to get that p-value to then compare it to your significance level. Alright, so again, 4 steps. State, plan, do, and conclude. All those need to be listed. In the state part, you need to have your parameters, statistic, hypotheses, and significance level. The plan, you need to name your plan you're using and then list all the conditions. You should have 3 conditions that you should name off. In this case, since dealing with proportions, you're going to want to deal with the large counts, okay? Again, for this, large counts is dealing with your P. Central limit theorem is dealing with your mu, right? So proportions for large counts and means for central limit theorem. The do part, again, go ahead and list out your general equation. Make sure to show that, as well as show the picture, as I did over here, our normal curve setup over here for the two-sided test. Make sure to do a picture like that and show your test statistic and shade which side you're trying to calculate to find your p-value. With that, showing your work as well to do that and the calculations, and then present your answer. Then your final step is doing your conclusion. Do that every time you have to do a significance test. All 4 steps. List it out. Can't stress that enough. As well as if you have a two-sided test, again, you're taking the p-value and multiplying it by 2 to compare that against your significance level to determine whether you reject the null or you fail to reject the null. Alright guys, so hopefully that explained things a little bit better for you, and I'll see you next time.